Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Welcome to Module 6, EtherChannel. Here we're going to be looking at EtherChannel operations, how to configure EtherChannel, and then verifying and troubleshooting. So let's go ahead and jump right on in. What is EtherChannel operations? So there are scenarios in which you need more bandwidth. You have a switch that has a ton of access for endpoint devices connecting to it, and they are sending lots of data. So how do we increase bandwidth? Sure, we could always buy a new switch that has additional speed. But what happens when we don't have the budget for that? We can actually take multiple links and combine them. This is what link aggregation is all about. Keep in mind, when you combine 2 links for them to function, if we have spanning tree enable, this could create a spanning switching loop. The problem with that is we need to be able to do link aggregation without STP being set off. So what we have to do is we actually enable the technology called EtherChannel. This will actually have multiple physical links act as a single virtual link, thus not having STP start blocking anything. The link aggregation technology is needed for those redundant links without STP putting them in a blocking state. EtherChannel technology will make it possible to combine the number of physical links between the switches to increase the overall switch communication speed. For example, here we have 2 links. You'll notice that we have the links and then a circle around them. That denotes EtherChannel. Here we have just 2 links. We can have multiple links, but it really is depending on the switch. Again, these are going to be called port channels. And this is going to be a virtual interface that we denote as a port channel. Again, we can have multiple physical links in that port channel group. Advantages of EtherChannel. Well, configuration tasks can be done on an EtherChannel interface instead of individual links. So you'll be treating the entire group as a single entity instead of having to look at each physical interface. EtherChannel relies on the existing switch ports. No need to upgrade the switch. Load balancing will take place over the links. EtherChannel will create aggregation that's seen as, again, a single link, preventing STP from blocking it. EtherChannel provides the redundancy because we have more than one connection. So if one connection does fall out, let's say we have 4 connections all in one port channel group, one link goes down, well, we still have 3 links in that group. So what are some of the restrictions? Well, first of all, interface types cannot be mixed. You cannot have gig and fast Ethernet. It needs to be one or the other. Another important part is currently each EtherChannel can only consist of up to 8 compatibly configured ports. The Cisco Catalyst 2960 Layer 2 switch can only support 6 EtherChannel. So again, if we are using newer switches, we can do 8 compatible configured ports. If we are using a Cisco 2960, we can only do 6 EtherChannel ports. Individual EtherChannel group member ports configuration must be consistent, and each EtherChannel has a logical port channel interface that's going to be the overall group. So, first of all, what protocol are we going to use when we're setting up our aggregation? Well, we have 2 types of negotiation ports. We have Port Aggregation Protocol, PAGP, or we have Link Aggregation Control Protocol, LAC. These protocols allow for the ports with similar characteristics to form that channel. It is possible to configure a static or unconditional Ether channel without either one of them. You can hard code them as well. Some non-Cisco products may use one over the other. I use a lot of Netgear switches, and by default, Netgear uses port aggregation of LAC. So how do we pronounce PAGP? We pronounce that PAGP. It is Cisco proprietary, meaning you can only use it on Cisco devices. When you enable PAGP, it will also manage the Ether channel. The packets are sent every 30 seconds, and this will check for configuration consistencies and manage link additions and failures between the switches. Again, all ports have to have the same type of configuration. If the Ether channel is mandatory that all ports have the same speed, duplex settings, and VLAN information. Any port modification after the creation of the channel also changes all of the port channels, all of the channels that are part of that port group. So when we're looking at PAGP, we have three modes: on, desirable, auto. On, basically this forces the interface to channel without PAGP. Desirable, this will place the mode in an interface in an active negotiation state in which the interface will initiate negotiations with other interfaces that will send a PAGP packet. Auto basically is the mode that will place the interface in a passive negotiation state in which the interface responds to PAGP packets that it receives, but it doesn't initiate, it doesn't send them. So, what happens if we have two switches and they're in different modes? Boop. Switch 1, switch 2. So if switch 1 is on and switch 2 is on, channel is established. Switch 1 is on and switch 2 is either desire or auto, no channel establishment. If switch 1 is desirable and switch 2 is desirable, then establishment. Desirable and auto, establishment. Auto, desirable, establishment. Auto and auto, no establishment. The sad part is you do need to know the charts for PAGP and LACP because these are going to let you know how the ports negotiate. So on LACP operations, this is part of IEEE's 802.3 AD. This allows, again, several physical ports, just like PAGP to function, but this is open source. LACP has three main types: on, active, and passive. The on will force the interface to channel without LACP. Interfaces configured in this will not exchange LACP packets. Active, basically the port will actively negotiate and actively initiate. Passive, it listens and responds. The chart for that is essentially the same thing. On and on, it does establish. On, active or passive, no. Active, active, yes. Active, passive, yes. Passive, active, yes. Passive, passive, no. So the names may be slightly different, but the established protocols are pretty dang similar. Alright, so how do we configure it? So we need to follow certain guidelines when looking at EtherChannel. First of all, EtherChannel support. This will be all Ethernet interfaces have to support EtherChannel with no requirements. Speed duplex matching, VLAN matching, range of VLANs matching, and as well as the modes need to match. So for configuration, for example, in this example, we see that the speeds are similar, duplex is similar, and VLANs are similar. This will allow us to actually form a aggregation, a link aggregation. So how do we configure this? So this is going to be how we configure LACP. You, first of all, need to do this either as a range or go to both interfaces. You need to set the channel group, you need to set the number of the group, and you need to set the mode. Here we are setting the mode to active. Once we set the channel group, that becomes the interface. So what I mean by that is, grab my pen. We have channel group 1. So channel group 1. That means it becomes port channel 1. That's how we reference that ether channel. We can set the mode, but then we can set what's allowed on that mode. So here we're setting it to a trunk, and we're allowing all the VLANs to operate at that trunk. Again, if this was channel group 10, we could reference that channel group by looking at the port channel number 10. We have a packet tracer where you actually have to do this with both LACP and PAGP. So how do we verify? There's a lot of show commands. We could show interface port channel, show ether channel summary, show ether channel port channel, and show interface ether channel. All of these provide specific details on our ether channels. And in our lab, we're going to be exploring each one of these show commands. So common issues with configuration is the modes. Is it set to on? Is it set to auto? Is it set to desirable? That's the big one. So for troubleshooting, in this example, we have a configuration of switch 1, switch 2, and we're assuming that we are trying to build a ether channel between these two. But the ether channels are not operating. How do we figure out what's going on? Show ether channel summary will let us see, well, first of all, this is the key of the flags. The number of channel groups in use, we got 1 channel. Number of aggregators, we have 1. And we can see the port group, the port channel, and the ports that are there. So we have FA01 and FA02 in a down state. D is a down. So SD, layer 2, capital S, and down. So for whatever reason, our links are down. So we can also look at the show run function to see what's going on. So show run on both switch 1 and on switch 2. Here we're looking at just the port channel information. So we have the interface port channel 1. We set this to a trunk. And we also set ether channel 1 and 2 to be part of channel group 1, channel group 1. And they're both set to on. Notice the mode. The mode is on. And then we come down here to switch 2. We see interface port channel 1. We see that it's set as a trunk. We set the interfaces. But we now start seeing the mode is set to desirable. We know that if one is set to on and one is set to desirable, it will not create a link. That just figured it out. But we can go one step further. We can figure out how to modify our configuration to fix it. On switch 1, we can change the mode on, and we can set the mode to desirable. We can, first of all, destroy the port channel. No interface port channel 1 deletes it. We reset up our interface range to our first and second interface. We reset up the group. So channel group 1, mode desirable, turn it on. Do the same thing down here, set the interface range, do the channel group, set it to a trunk mode, and we should be good. That would force the mode to be replaced from on to desirable. We can do a show Ethernet summary again, and we now have an SU, layer 2, and in use. Protocol is PAGP, and both of our interfaces are in a P state, in a bundled in port channel state, so operating. Questions, concerns, please reach out. Thank you.